Hi everyone, this is Aman Sophia, Assistant Professor in Triple Department. Welcome to Witsconnect. Let's start our subject, power semiconductor drives. Today we are going to discuss about the block diagram of electric drive. The block diagram of electric drive mainly consists of 4 parts: source, power modulator, motor and load. At here, from the source, supply is transferred to motor and load through power modulator. Coming to the block diagram, power modulator will play a main role as it performs one or more functions. First of all, it modulates the power flow from the source to the motors, and it will act as a converter. For example, if the source is DC and the induction motor is to be employed, the power modulator is required to convert DC to AC, and it will select the mode of operation of the motor. Either it may be motoring or braking. Next, during transition operation, it restricts the source and motor current with permissible values. Next, input command will send a signal to the control unit to operate the point of the drive. Here, control unit will protect the power modulator, and control unit usually operate at much lower voltage and power levels. And here sensing unit will sense the drive parameters like current, speed and etc. Whereas load is usually a machinery designed to accomplish a given task. Example of load is fans, pumps, robots, washing machines, so on. Coming to parts of electrical drives, there are mainly 4 parts: electrical motors, power modulators, sources and control unit. First part is of electrical motor. Motors commonly used in electrical drives are DC motors like shunt motors, series motors, compound and permanent magnet motors, induction motors, synchronous motors, brushless DC motors. So the motors. Next, in the past, induction and synchronous motors were employed mainly in constant speed drives. Whereas for variable speed drives, consisting of these machines were either too expensive or poor efficiency. Consequently, variable speed drive applications were dominated by the DC motors. That's the reason AC motors are now employed in variable speed drives by using different types of semiconductors like thyristors, power transistors, IGBTs and GTOs. Why we are going for AC motors means due to the presence of commutator and brushes, DC motors have number of disadvantages as compared to AC motors like higher cost, its weight, volume and inertia and frequent maintenance. These are the disadvantages. Next, coming to power modulator, as I said, power modulator will perform more number of functions. First of all, it will control the source and motor current within the permissible limits during the transition operations. Next, it will act as a converter, and next it will adjust the motor operation either motoring, braking or regenerating. Coming to converters, as I said that it will act as a converter. There are different types of converters. First one is of rectifier, which will convert the fixed AC voltage to fixed DC voltage. Next, AC voltage controller, which converts the fixed AC voltage to the variable AC voltage. Next, chopper converters are DC to DC converters, which converts the fixed voltage DC to the variable DC voltage. Next, inverters, which converts the DC voltage to the AC voltage, and cycloconverters, which converts the fixed frequency and fixed voltage AC to the variable frequency and variable voltage AC. Sources. So either the source may be of DC system or AC system. If it is a DC source, it is used for the DC system. If it is AC, so it is used for the AC system. In our country, we are having 230 volts 50 hertz single phase and 415 volts 50 hertz three phase power. Coming to the control unit, the main function of the control unit is it will protect the power modulator. And when semiconductor converters are used, the control unit will consist of firing circuits, which employs linear and digital integrated circuit and transistors, and a microprocessor when sophisticated control is required. Coming to the main classification of the electric drives, there are two types of electric drives, DC drives and AC drives. Next, coming to the applications of electric drives, these can electric drives can be used in paper mills, cement mills, textile mills, and sugar mills, and uh, it can also be used at electric traction, electric vehicles, steel mills. They are the applications of electric drives. Next is choice of electric drives. That means on which factors we are choosing the electric drives. There are there are some factors, different types of factors. First one is of steady state operating condition requirements, nothing but based on the nature of speed torque characteristics, speed regulations, efficiency, its ratings. Based on this, we are selecting the electric drive. Next one is of transition operation requirements, nothing but uh, its starting characteristics, braking characteristics, and reversing performance. Third one is of requirements related to the source, nothing but type of source, its capacity, voltage, power factor, harmonics, and their effects on other loads. These are the requirements related to the source. And the next one is of based on its capital and running cost, its maintenance. The next one is of space and weight restrictions. The next one is of environment and location. The last one is based on its reliability. Coming to status of DC and AC drives. See, in the past, induction and synchronous motors drives were mainly used in fixed speed applications. Variable speed applications were dominated by the DC motor drives. Because of the advantages of squirrel cage induction motors over DC motors, it was predicted that induction motor drives will replace DC drives in variable speed applications. How means squirrel cage induction motor was cheaper than DC motors. The converter and control circuit of induction motor drive was very expensive compared to the DC drives. Therefore, the total cost of induction motor drive was significantly higher than of DC drive. The next one is of well, the technology of DC drive was well established than that of AC was new, and AC drives were not as reliable as DC.